A colossal iceberg, more giant than a city, broke away from Antarctica in mid-2021. It's so big that it's 40 times bigger than Paris and 73 times the size of Manhattan. Imagine that you come out of your small holiday shack on the coast of South Africa, near the town of Port Elizabeth. You have a cup of tea in your hand as you've just woken up. You stand near the edge of your lookout, the vast Indian Ocean before you. Something catches your eye. To the right, there is something so monumental, you can't comprehend it. It's a giant slab of ice, 300 feet high, and stretching away many miles, as far as the eye can see. It rolls slowly, but relentlessly on, heading out into the deep sea. If it goes far enough, it could reach the western coast of Australia. Playing in front of it are a pod of dolphins, like they sometimes do off the bow of a ship. Yet they're just specks compared to the mammoth size. You're so shocked that you drop your cup. Your eyes are as big as saucers. It's like something out of a science fiction movie. Are you dreaming? Are you seeing things? Nope. It's A76. It's real, and it's currently on the move. What could happen to it is anyone's guess. Well, scientists have a few theories, but let's get a grasp of its size first. The iceberg is 110 miles long and 16 miles wide. It's basically the shape of a gigantic finger. If you were standing at the coast of Dover, looking across the English Channel toward France, the iceberg would be almost as wide. The channel is 21 miles across at its narrowest. That means approximately 2/3 of that distance would be filled with the iceberg. That's if it were drifting finger pointing down, so to speak. If it were facing the other way, it could still enter the English Channel, but as it got closer to the narrowest points, it would smash into the coasts of both England and France. It would go up over land. It would slide over the green fields of England, the white ice bold against the rich green. It would cruise past the vineyards of France. It was temporarily lowering the temperature of everything around it. Those grapes would be like jelly crystals. It would skim right over highways, cars stopping to observe this colossal thing like a visitor from another galaxy. You could pluck chunks off it for your drink as it sailed past. Failing that, you could scale it and go ice climbing, right on the outskirts of London. It would certainly be handy in the summer. But let's get back to what actually happened, and what scientists think will happen to it. As of the beginning of 2022, A76 is the world's most giant floating iceberg. It was calved from the Filchner Ronne ice shelf in Antarctica in the middle of May 2021. Ice calving, also known as glacier calving, is the breaking up of ice chunks from the edge of a glacier. It then pulls away from the ice mass into a separate entity. If you were nearby, you would hear a lot of cracking and a massive booming sound. Blocks of ice up to 200 feet would break free and crash into the water. It would cause huge waves. Not even adventurous surfers would want to tackle those breakers. Ice calving is a natural event. The area where A76 broke off has seen little change in recent decades. There have been even larger chunks of ice than A76, but this one is currently the largest in the world. Scientists at the British Antarctic Survey spotted it. There are satellite images of it breaking free, as captured by the European Space Agency's Sentinel-1A satellite. The size at the calving was an estimated 1,670 square miles. Right now, it's in the Weddell Sea around Antarctica. The Weddell Sea is part of the Southern Ocean. It was named after the Scottish sailor James Weddell, who entered the area in 1823. Scientists have deemed the Weddell Sea to have the clearest water of any sea. Imagine peering down into its depths from a boat. What a fantastic view it must be. The area is full of whales and seals. As you look down, you may see killer whales, humpback whales, minke whales, leopard seals, and crab-eater seals. And if you look towards land, you'll likely see a colony of Adelie penguins. They're the dominant penguin species in this area because they adapt to the harsh environment. In fact, this is the only location in the world they live. What an incredible array of wildlife to observe, all from the comfort of the ship's deck, while you drink another cup of hot tea. It gets pretty cold in these parts. To get an idea of what could happen to A76, scientists refer to other data, such as the even more enormous iceberg called A68. It was calved from the ice shelf known as Larsen C off Antarctica in 2017. While it may be exciting, though a little daunting, to think of it also sailing up the English Channel, A68 floated out to warmer seas and, by early 2021, had all but dissipated. That was a relatively quick demise. Some icebergs have been observed floating around for up to 18 years. Suppose they remain in the relatively cold waters. It all depends on where A76 decides to go. Satellites have helped scientists keep track of these monstrous movements, whereas they would go unnoticed in the past. That's how they know that by day 148, this iceberg had split into 3 fragments, imaginatively titled A76A, A76B, and A76C. The numbers might be boring, but they're based on the Antarctic quadrant in which they were first sighted. If these enormous chunks do break up entirely, it will not add to rising sea levels because it was already part of the floating ice shelf. Imagine these ice chunks in your glass. They already take up a certain amount of space. They will simply change form into water. Icebergs like this one are different from glaciers or ice sheets found on land. Those are the things that help to raise sea levels when they break off and melt. For example, if the whole of Antarctica's ice sheet were to melt, it could raise sea levels by nearly 190 feet. If you think A76 is enormous, and it clearly is, there was another that makes it look small in comparison. On record, the largest iceberg was sighted in November of 1956, 150 miles west of Scott Island in the South Pacific Ocean. Ironically, it was seen by a ship known as the USS Glacier. It was sized over 12,000 square miles. This iceberg was larger than the country of Belgium. What may happen to the chunks of A76 will depend on a few factors. Ocean currents can make a significant impact, and wind direction and speed can too. They may move closer to coastlines, where they can freeze into pack ice. They can also drift into shallow waters and hit the seabed, called seabed gouging. The deepest part of the iceberg can act like the keel of a boat. It digs into the ocean floor, but the sheer size of the iceberg keeps it moving. Soon it's tearing up the floor, creating a long, narrow furrow or a gouge. Fish would scatter, the earth would shake, the noise would be tremendous. It's actually quite common in offshore environments near where ice is found. You would not want to be scuba diving nearby when one of these rips through. However, it would make for a spectacular sight. Generally, icebergs deteriorate through melting and fracturing, which, as you can imagine, changes the mass and the surface area. Combined with wind and ocean currents, it can make iceberg modeling difficult. As for A76, we'll just have to wait and see. Before we go, let's return to our imaginary voyage down the English Channel. The island of ice, 73 times the size of Manhattan, with its gigantic frosty finger pointed down toward the Celtic Sea, rolling steadily onwards, unable to be stopped. Hundreds of thousands of people have flocked to the coasts of both England and France to watch this extraordinary spectacle as it cruises by. On top of the ice, there are thousands of penguins playing happily. They almost look to be waving back to the abundance of sightseers who cheer them on their way, the children jumping with joy at the most spectacular sight they've ever witnessed.
We are on the Sea of Marmara, the exact spot where the massive continents of Europe and Asia meet. It's a vital, beautiful waterway packed with cargo ships on the surface, but dive underneath and you'll find a geographical nightmare lying on the seafloor. Deep underwater, 2 massive slabs of the Earth's crust are violently grinding past each other. This isn't just a minor crack in the dirt, it's a colossal geological fault. A massive complex system of continuous fractures that has been accumulating a devastating amount of energy for decades. We call it the Great North Anatolian Fault. All this energy has to be unleashed someday. And when it happens, it's going to hit one of the most densely populated areas on our planet. Scientists are now in active monitoring mode, especially when it comes to Turkey. This country is sitting on the Anatolian Plate, a small bite of the Earth's crust. Nowadays, it's being literally smashed by the Arabian Plate from the south and the Eurasian Plate from the north. Because it's being squeezed so hard, the only direction it can move is west toward the Aegean Sea, and it actually does this at a speed of about 1 inch per year. In geological terms, that's a high-speed, violent movement. Millions of tons of solid rock grinding against each other deep underground day and night without a single break? Not the best thing to experience. All this endless moving, cracking, and squeezing is what creates the North Anatolian Fault, a 930-mile-long fault line that acts almost exactly like the infamous San Andreas Fault. Yet the difference is striking. While the San Andreas mostly skirts the outer edges of Californian megacities or runs through less dense regions, the fault in Turkey is running right under major industrial hubs and heavily populated urban centers. In February 2023, the smaller sister of it, the East Anatolian Fault, showed us how dangerous this tectonic setup can be. It generated the most catastrophic earthquake recorded in Turkey in over 60 years, a brutal 7.8 monster hit and a 7.5 shockwave followed right behind it just hours later. The release of energy was so violent that the ground literally moved by almost 10 feet in some places. Entire cities were leveled and the physical map of the region permanently shifted. Now the worst part, it wasn't even the grand finale. There's no way to stop that energy packed inside the North Anatolian Faults. Look at the old data and you'll see it acts like clockwork, a bit like a line of falling dominoes. Scientists have been tracking every sequence of earthquakes in this region for nearly a century. The whole chain reaction started in 1939 with the catastrophic Erzincan earthquake. A massive magnitude 7.8 struck eastern Turkey. It didn't simply release the energy, but also transferred this tectonic stress into the next section of the fault. Dominoes started falling. Other fault ruptures happened in 1942, 1943, and 1944. It went west and struck again in 1957 and 1967. Year by year, the epicenters of these massive earthquakes moved in a straight line toward the Sea of Marmara. The last major impact was the Izmit earthquake in 1999. A magnitude 7.6 tremor struck east of Istanbul and lasted for 37 terrifying seconds. Suddenly, the chain reaction took a break, but the tectonic stress was still there, simply transferred to the next section of the fault, under the Sea of Marmara, where the last major earthquake took place in 1766. Nobody had seismographs back then, but historical records and old journals describe it as a scene of unimaginable horror. Now, modern science tells us exactly why it was so devastating. Scientists are calling it a seismic gap, basically a dangerously quiet zone that hasn't ruptured yet. Back then, 260 years ago, a massive quake destroyed a huge part of Istanbul and generated a tsunami that crashed into the city's ports. After this tragedy, it didn't happen again on this scale, but we have to remember that the Anatolian Plate has never stopped moving west, an inch a year. Let's do some quick math. That land should have moved by over 19 feet by now, but because those rocks are locked together, they haven't moved an inch. We are looking at a massive backlog of tectonic tension. It simply has to snap finally, and it won't make a regular shake. It will likely rapidly release 2.5 centuries of accumulated tectonic energy, right at the doorstep of Europe and Asia. The target is the city of Istanbul once again. We should call it a supercity because this global mega hub is home to an astonishing 15 million people. It accounts for nearly 30% of Turkey's entire economic output. What about the infrastructure? We're talking about 1 million buildings, and an estimated 90,000 of those are at high risk of total collapse in the event of a magnitude 7.5 earthquake. Nowadays, the city has very strict laws for modern buildings. But plenty of urban areas had been built before those regulations were enforced. To make matters worse, many coastal neighborhoods are built on soft, waterlogged soil that acts like a liquid during extreme shaking, multiplying the danger for the residents. Buildings could just sink into quicksand. And there's more. The seafloor of the Marmara Sea isn't flat. There are 3 massive deep underwater holes separated by vast ridges. Why is it important? A stronger earthquake in this area will probably trigger a massive submarine landslide. Plenty of mud and rock collapsing down those underwater canyons would instantly displace massive amounts of water. This would trigger a tsunami, not as tall as mega tsunamis in the open Pacific Ocean, but still highly dangerous. It's estimated that with a 10-foot wall of water, it will be extremely dangerous for this densely populated area. Scientists also claim that it could hit the coastline within 10 minutes. There would be almost no time for a mass evacuation. Here comes modern technology. Engineers are fully aware that this geographical clock is ticking and are fighting back. Essentially, infrastructure is being heavily retrofitted. Also, the mighty bridges crossing the Bosphorus Strait have been reinforced with seismic dampers to absorb extreme shocks. One of the world's largest seismically isolated buildings is located at Sabiha Gökçen International Airport in Istanbul. It's sitting on massive bearings made out of rubber and steel. The absolute art of engineering is the Marmara Tunnel, a massive railway tube that runs directly under the Bosphorus Strait, physically connecting the European and Asian continents underwater. It was built right next to an active fault line, so it had to be designed with flexible earthquake-proof joints. If a megaquake hits and the continents shift, the tunnel will bend and flex like a giant snake rather than snapping in half. Another concern of scientists is the economic aftershock of this rupture. It may affect the entire globe, as the Bosphorus Strait is one of the world's most critical maritime choke points. Every single year, nearly 50,000 ships pass through this narrow waterway, carrying everything that is crucial for the global market: barrels of oil, agricultural goods, and so on. The price of energy and food would go crazy if this shipping line collapses. To buy some precious time, scientists have installed an advanced early warning network on the seafloor of the Marmara Sea. Fiber optic cables and seismometers are constantly listening to the fault. But because the epicenter is located so incredibly close to the city, even this multi-million-dollar system won't give residents enough time to escape. At best, it will provide a maximum of 5 to 7 seconds of warning before the destructive waves hit the city. 5 seconds to shut down gas lines, halt the trains, and brace for the impact. Of course, all this effort won't protect the whole city. Only a fraction will survive. The undeniable conclusion is that the migration of earthquakes isn't just a theory, but a well-documented geographical reality. Scientists estimate that there is a 65% probability of a magnitude 7 or greater earthquake striking the Sea of Marmara region before the year 2030. Now we can see that the rupture in this area isn't just a possibility. It is coming, and it is migrating directly toward the collision point of 2 continents.
The prehistoric landmass Doggerland wasn't some empty wasteland during the last ice age, like scientists used to believe. It was alive, full of trees, animals, and maybe even people. And then the North Sea swallowed all of it like it never existed. So, no, Doggerland was not some ancient gigantic dog pound, although that would have been cool. It was a massive stretch of land that used to connect Great Britain to mainland Europe. You could have walked on it from modern-day England to the Netherlands without seeing water. Rivers cut through it, animals migrated across it, and early humans likely followed those same routes, finding prey, gathering, and building their lives on this land. Then, glaciers melted and sea levels began to rise. Doggerland was drowning slowly. Land turned into wetlands, and wetlands broke into islands. Islands shrank year by year. Forest paths turned into marshes, and rivers widened into channels. And eventually, somewhere between 10,000 and 7,000 years ago, the sea finished the job. But now, scientists have pulled out evidence of a full forest ecosystem that existed here over 16,000 years ago. thousands of years earlier than previously thought. They used sedimentary ancient DNA analysis to figure it out. Every living thing leaves behind tiny traces of itself, microscopic fragments of DNA, and those fragments can get trapped in mud and sand. Over thousands of years, layers build up, and those fragments stay there, like fingerprints pressed into wet cement. Scientists drill down, pull up those layers, and read them like a timeline. When they analyzed sedimentary ancient DNA from 252 samples from 41 marine sediment cores, they found traces of oak trees, elm, hazel, real temperate forest species. And they weren't just surviving there, but thriving more than 16,000 years ago. That's deep into the last ice age, a time we've always imagined as brutal and lifeless, especially in northern Europe. But instead of a frozen desert, it looks like this area was a hidden pocket of life. And this wasn't just a temporary burst of life after the ice, but a deep-rooted ecosystem. It was stable enough to support large trees with massive root systems. You don't get that unless the soil holds together, unless there are seasons, growth cycles, and enough balance for life to settle in and stay. Among all the DNA, scientists found traces of a tree called Pterocarya, a distant cousin of modern walnut trees. The weird part is that researchers believed it disappeared from that region around 400,000 years ago. But somehow, it held on here, and that detail changes how we understand extinction. It could mean that species don't always vanish completely. Sometimes they retreat, hide, and survive in small pockets we just haven't discovered yet. All this means that parts of Doggerland probably remained above water during major flooding events, like the Stagaga tsunami around 8,150 years ago. This means this land didn't just vanish, it resisted. It broke apart slowly, holding on in fragments before it finally disappeared. But actually, all of that still exists. It's not alive or visible, but preserved under layers of seabed and miles of seawater. Ships pass over it every day. Waves roll across it. If you could somehow drain the North Sea for a moment, you would see those old river channels carved into the earth, soil layers, and maybe even preserved roots where trees once stood. Another cool detail is that scientists think Doggerland might explain why traces of early humans in Britain seem so scattered. If people lived there, and it's very likely they did, then when the sea swallowed the land, it swallowed their history with it. Campsites, tools, pathways, and entire communities were all gone. Now, Doggerland isn't some one-time anomaly, so let's jump to the extreme opposite, Antarctica, with its endless ice, brutal winds, and temperatures that don't forgive anything. You look at it and think nothing survives here. But scientists walked across it and proved that idea completely wrong. Between late 2019 and early 2020, a team trekked across a remote part of Antarctica. Their instruments picked up something strange under their feet. Not solid ice as they expected, but something softer. So they drilled. Layer after layer of ice came out, until about 40 feet down, they hit something impossible: liquid water. It was a lake hidden under ice in one of the harshest environments on Earth. They tested the water, trying to understand where it came from. Because this place doesn't get much snowfall, the wind strips moisture away. Sunlight evaporates whatever little exists. So, how does a lake survive here? The answer is chemistry. Tiny traces of dissolved materials in the water help scientists find a hidden source. It turned out that a nearby glacier feeds the lake through underwater pathways no one knew existed. And then they looked closer and found microbial mats, living carpets made of microscopic organisms inside that dark sealed environment. Some stretch flat across the lake bed like rugs. Others grow upward in spiky shapes that rise up to about 15 inches tall. That's over a foot of life growing in total darkness, under thick ice, completely cut off from the outside world. And this life doesn't just exist, but organizes and changes over time. It's structured like a miniature forest floor, just in a completely unusual form. Another Antarctica discovery that shocked scientists was bubbles. They sit inside what might be the oldest ice ever brought up into daylight, nearly 1.2 million years old. Now, before this, researchers could only track Earth's climate history back about 800,000 years. That already felt ancient, but it still left a huge chunk of our planet's story missing. So scientists went looking for the right ice to fill in the gaps. Some parts of Antarctica actually hold ice that could be 3 or even 4 million years old, but it's messy and incomplete. They needed a clean timeline, layer after layer, year after year. So they spent years searching for that perfect spot, scanning the frozen continent like detectives looking for a buried archive. And when they finally drilled down into the ice at just the right location, they hit something special: crystal clear ice cores, stacked like a frozen timeline with tiny bubbles inside. Each one came with a microscopic sample of ancient air, sealed off from the world for hundreds of thousands, sometimes over 1 million years. When scientists study those bubbles, they can figure out what the atmosphere looked like, what gases filled the sky, how much carbon dioxide floated around, and how the planet's climate shifted over time. One moment locked inside that ice stands out more than most: the period around 900,000 years ago. That time might have been one of the closest calls our species ever faced. According to genetic studies, back then, the human population dropped to around 1,300 individuals worldwide. Nobody knows exactly what caused it, but climate is one of the biggest suspects. Massive environmental shifts, changing temperatures, unstable ecosystems, everything could have stacked against early humans at once. And those bubbles might hold clues to what kind of world those few survivors had to endure. So when scientists look inside one of those ancient bubbles, they're tracing survival. They're asking how a handful of humans made it through one of the toughest chapters in Earth's history, and what that might mean for us today. And when scientists scanned Antarctica from space, they found something even harder to wrap your head around. Beneath over 6,000 feet of ice, they detected an ancient landscape. Not rough shapes, but actual terrain with valleys carved by rivers and land split into blocks by tectonic forces millions of years ago. A place where water once flowed freely across the surface. This landscape dates back around 34 million years ago, to a time before Antarctica froze over completely. And somehow, in this one region, the ice didn't grind it away. It just sat on top of it, frozen in place, and preserved it like a time capsule. Scientists described it as a ghost, because it shouldn't still exist. Most landscapes get reshaped, erased, recycled by Earth over time, but this one just stayed. When you connect all of this, you can see that Earth doesn't change slowly and predictably. It hides things like entire ecosystems and histories. We walk around thinking we know this planet, but underneath us, under oceans and ice and layers of time, there are entire worlds we haven't even touched yet.
Sea levels. Sea levels.
The glaciers are melting.
Sea levels are rising almost everywhere on Earth. Beaches are shrinking and coastlines are prepping for trouble, but not in Greenland. Ironically, the same giant ice sheet that can flood the planet could also make parts of Greenland rise out of the ocean by the end of this century. What kind of physics glitch is this? The answer starts with the weight of ice. Greenland is buried under a ridiculous amount of ice. It covers about 80% of the island and spreads across roughly 660,000 square miles, about 3 times the size of Texas. In some places, it's more than a mile thick. At its deepest, it's close to 2 miles. If all of it melted, global sea levels would jump by about 23 feet. Coastal cities like Miami Beach would stop looking like vacation spots and start looking like tourist attractions for divers. And underneath all that ice is actually land. Greenland is not a floating iceberg. It's a real island with mountains, valleys, and rivers. For ages, all that ice has been pressing down on Earth's crust like a giant thumb pushing into soft ground. The crust isn't completely stiff. It sits on top of deeper rock that can slowly change shape over time. The enormous weight of the ice has depressed parts of Greenland's crust, and some bedrock beneath the ice now lies below sea level. Basically, the weight of the ice has made the island sag a bit. But now the island is losing ice relatively fast. Every year, hundreds of billions of tons end up in the ocean. When you lift something heavy off the ground, the Earth starts to push back up to where it was before. Greenland works in a similar way. As the ice melts away, the land underneath starts to bounce back up like a spring that's been squished. Everything with mass has gravity. Planets have it, moons have it, skyscrapers and mountains have it. Your house has it, your coffee mug too, even you and me. But it's so small it's basically impossible to measure. However, Greenland's gravity, even though small, acts like a magnet for the nearby ocean. It pulls the water right toward its shores. That nudge is tiny, but still makes a difference. So when Greenland starts to lose its mass, the gravitational grip will weaken. This makes the water slosh away into the open ocean. Scientists already theorized Greenland would bounce back as it shed ice. But new research shows that some of the rebound might happen faster. The secret could be buried deep underground. Rocks way down could be helping to lift the land, meaning this isn't a slow change that's going to happen ages from now. Some coastlines might keep rising throughout this century, with the biggest shifts likely happening by 2100. In some parts of Greenland, scientists think the land could actually go up by a few feet over the next few generations, which is pretty significant when you consider how things move in geological terms. One reason southeast Greenland stands out is its weird geological history. Millions of years ago, this part of the island passed over the Iceland plume, a deep upswelling of superheated rock. That ancient heat may have left the upper mantle weaker than usual, which could explain why uplift there is happening faster than scientists expected. Underneath all that ice, Greenland has some surprising secrets. Scientists have discovered a huge canyon buried beneath the ice sheet that's 460 miles long, way longer than the Grand Canyon. This ravine is hidden in complete darkness below the frozen surface, but subglacial rivers are still going through it, carrying meltwater out to the Arctic Ocean. Researchers have even pulled up drill cores that show ancient soil and plant remains. It turns out that millions of years ago, this frozen island was actually green and covered in vegetation. The melting ice is even exposing a top-secret ghost town. Back in the 60s, the military built a hidden base powered by a nuclear reactor straight into the ice sheet. The project was called Project Iceworm, which aimed to test whether nuclear missiles could be hidden under the ice. Scientists assumed the ice was stable, but the moving ice quickly crushed and warped the tunnels, forcing them to shut down. They thought it would stay safely buried forever, but now, thanks to the shrinking glacier, those abandoned tunnels and heavy machinery are slowly coming right back up to the surface. The melting ice triggers another cool chain reaction. Moving billions of tons of water off the island shifts the weight across the entire globe. But most of that mass heads towards the equator. When Earth gets heavier around the middle, its rotation slows down. It works kinda like a spinning ice skater stretching their arms out. The entire planet actually takes longer to complete a full spin. Yes, the melting ice is actually making a day longer. The actual shape of the planet changes along with it. Earth is already slightly lumpy rather than a perfect sphere. The sheer mass of the Greenland ice sheet helps warp the crust. As the ice melts and the ground bounces back, the physical geometry of the globe shifts. So not only does it make the day longer, it can actually bend the world out of shape, literally. Back on the surface, the consequences get very local very fast. Greenland's towns are mostly built along the coast, and many depend on fishing. But when the land rises, the water near the shore gets shallower, harbors can turn muddy, ships can get stuck, and towns may need to dredge channels just to keep supplies moving. The coastline also starts changing shape. New rocks and small islands can appear, and routes that used to be safe can suddenly become risky. And the ice sheet itself is anything but quiet. Huge outlet glaciers like Helheim keep pushing toward the ocean, cracking and grinding as they go. When giant slabs break off and crash into the sea, the impact can be strong enough to trigger glacial earthquakes. Those shockwaves travel through the planet, and seismographs thousands of miles away can pick them up. At the same time, meltwater can slip underneath the ice and make the whole glacier slide faster, like a heavy object suddenly hitting a wet floor. Once meltwater starts moving through the cracks in the ice, it can weaken the glacier from above and below at the same time. The shifting landscape can trigger even bigger chaos. In 2023, part of the mountain in East Greenland collapsed into a narrow fjord and launched a wave about 650 feet tall near the impact. The walls of the fjord trapped the water, turning the whole place into a giant sloshing basin. The water sloshed back and forth so violently that the entire planet vibrated for 9 straight days. Another interesting thing is that the snow on top is messing things up for the ice underneath. When it gets warmer, tiny algae start blooming like crazy and turn the snow pink. Locals call it watermelon snow. It might sound cute, but it's a big problem. Bright white snow reflects sunlight really well, but when it turns pink, it starts soaking up heat like a dark shirt on a hot day, which makes it melt way faster. The ice also gets covered with tiny particles like dust, soot, and microbes. Because they are darker than clean ice, they absorb more sunlight and melt little pits into the surface. Millions of these tiny pits can turn the solid surface into something like frozen Swiss cheese. Scientists call them cryoconite holes. They form when dust, soot, microbes, and organic material clump into dark grains that absorb sunlight, melting narrow little shafts that can even host tiny microbial ecosystems inside the ice. And that's what makes Greenland so fascinating. At the start, this looks like a physics glitch. An island losing ice should mean more water and higher seas. But Greenland doesn't play by one simple rule. As the ice shrinks, the land rises, the nearby ocean shifts, and deep rock starts responding too. What looked like a contradiction is really a whole chain reaction hiding inside one frozen island.
You're sailing on a calm ocean when you see it, a giant wave rising out of the water, towering over your boat. Uh-oh. But before you can react, the deck suddenly disappears beneath your feet, and you're falling into a deep and vast pit in the sea. Neither outcome gives you a chance to survive. Apparently, the ocean can both crash down on you and suddenly drop away beneath your feet. It's not your day. Well, in the first case, it will be a giant rogue wave. These waves are huge and dangerous ocean waves that appear suddenly and are at least twice as tall as the waves around them. These waves can rise up in the open ocean without warning and may move in a different direction than the wind and other waves. They're extremely dangerous, even for big ships, because they form super quickly and grow to be exceptionally large. But there's even a scarier threat in the ocean: rogue holes. Those are massive pits in the water, and until recently, no one could confirm their existence. They are the opposite of rogue waves. Instead of a huge wave rising up, they are deep dips in the ocean that appear suddenly, sometimes just before or after a big wave. The water drops sharply, often surrounded by normal-sized waves on either side. When the difference between the top of the waves and the bottom of the dip is much bigger than normal, it can be just as dangerous for ships as a giant 80 to 100-foot wave. Now, scientists have figured out that big waves and deep dips often happen together, so the danger they present now doubles. ESA's MaxWave project was studying rogue waves when they found evidence of rogue holes. After that, researchers even recreated rogue holes in a large water tank to study them safely. And they found out that, apparently, rogue waves and rogue holes come from the same hidden pattern in the ocean. You see, the MaxWave project didn't officially list rogue holes as a separate type of wave. But scientists did notice something unusual in their data. They saw deep drops in the ocean surface appearing together with very large wave peaks. This suggested that rogue holes might exist, but there was not enough evidence to confirm it. To test this idea, a team of researchers at Kyoto University recreated ocean-like waves in a long wave tank, about 50 feet long. It worked like a controlled mini-ocean where scientists could carefully adjust wave size and speed. Inside this tank, they were able to create both giant rogue waves and deep rogue holes. The rogue holes looked like sudden voids in the water, deep dips surrounded by normal-sized waves, like the ocean briefly sank down in one spot. It's similar to a sudden pothole appearing on the road, but filled with moving water instead of asphalt. So imagine normal waves as fast repeating bumps moving across the water. Now imagine a much slower, bigger wave on top of that. It looks like a rolling hill that lifts everything up and down. This bigger wave controls how strong the smaller waves are. If the hill hits a wave right when it's already at its highest point, the wave grows into a huge rogue wave, as if someone stacked one wave on top of another. But if that same hill pushes down when a wave is at its lowest point, it creates a deep hole in the water instead. It's like the ocean suddenly drops beneath your feet. So it's the same process, just timed differently. At times, it creates a giant wall of water, and at other times, it's a sudden dangerous drop. So the results of the experiment matched the mathematical predictions. They proved that those strange wave patterns were not just a theory, but something that can really happen in the ocean. In 2016, scientists compared mathematical models with real ocean measurements and found patterns that match both giant waves and deep holes in nature. Of course, in the real ocean, these shapes are not perfectly smooth like in experiments. The waves often have sharper, uneven edges, like a hill that is steeper on one side than the other. But even with these differences, they still followed the same hidden structure. This confirms that rogue waves and rogue holes are really two kinds of the same ocean event. They're just shaped differently by timing and energy. Meanwhile, we still really don't know the ocean. Most of it is a mystery to us. Less than 1/1000th of the seafloor has been seen up close. Imagine the size of Rhode Island or Luxembourg, hey, pick one. That tiny bit is what we have mapped. Everything else, deep trenches, cracks, caves, massive underwater mountains, remain blurry on our maps. Many phenomena went unexplained for centuries, too. For example, sailors kept reporting enormous waves that suddenly towered over everything else, sometimes more than twice the height of normal waves. Back then, most people thought these reports were exaggerations, like spotting mermaids or a giant squid. But those waves were real. Now, in 1826, Dumont d'Urville, a French naval officer and explorer, sailed the Indian Ocean on the ship Astrolabe. Yeah, it's a bad French accent. He saw waves of at least 80 to 100 feet tall during a violent storm that took the life of a crew member. At that time, scientists thought waves couldn't exceed about 30 feet. So, even though his account sounded unbelievable, D'Urville insisted on recording it. And guess what? Yup, instead of being praised, he was laughed at. Okay, I'll stop. Now, even earlier, in August 1498, during his third voyage to the Americas, Christopher Columbus and his crew heard an enormous roar from the sea and saw a wave rising behind their ships. It was as tall as the masts. The wave lifted the ships higher than anything they had ever experienced, and then dropped them into a massive trough. It was like a roller coaster made of water. Now, modern oceanography has confirmed that such colossal waves do exist. They're like skyscrapers suddenly appearing in the middle of a calm sea. A normal wave might be tall enough to reach the roof of a 2-story house, but a rogue wave can tower like a 10-story building. In 1861, such a wave apparently smashed a lighthouse in Ireland. It shattered lamps and sent debris tumbling down a lighthouse staircase. To do that, the water had to climb a 130-foot cliff and then an additional 85 feet of the lighthouse structure. It's almost as tall as a 20-story building. Rogue waves appear suddenly, often without warning, in the middle of the ocean. These waves form when winds, currents, and smaller waves line up just right, making a single giant wave much taller than the others around it. They aren't tsunamis and aren't caused by earthquakes or volcanoes. Physicists model this using something called the nonlinear Schrödinger equation, but basically, it just explains how the ocean can suddenly make a giant wall of water. On January 1, 1995, the Dropner wave struck an offshore gas platform in the North Sea off Norway. It measured 84 feet. This was the first time a rogue wave was officially recorded, proving those monster waves were real. But scientists still consider them rare. Well, by the year 2000, the European Space Agency's Max Wave project confirmed that rogue waves were more common than anyone thought. Using radar from ESA satellites, scientists studied the global ocean and found many waves exceeding 82 feet. Some of the largest recorded waves even reached 98 feet near Newfoundland. Suddenly, what people used to brush off as sailor stories turned out to be terrifyingly real. On the 17th of November 2020, a weather buoy near Vancouver Island, Canada, recorded a very unusual wave in the Pacific Ocean. The wave reached about 58 feet, while the surrounding waves were only about 20 feet. This made it much larger than normal waves around it. On the 29th of November 2022, a rogue wave hit the cruise ship Viking Polaris near Antarctica. One person lost their life, several others were hurt, and the trip was canceled. On the 18th of September 2023, a large wave hit a beach restaurant in South Africa. 7 people were injured, and one person was swept out to sea but luckily rescued. And on the 20th of January 2024, powerful waves hit a U.S. military site in the Marshall Islands. Buildings were damaged, some areas were flooded, and waves moved far inland, showing how destructive these events can be. Alright, listen up. One of the greatest threats to humanity comes from large corporations planning to extract minerals from the ocean floor. The point of no return could be reached this year. The ocean could stop breathing in some places, yet some people see no problem in this, or perhaps they simply refuse to see it. And here's the kind of cheerful news you might hear about it. Many terrestrial resources are depleting, and the demand from major corporations for valuable metals and minerals is growing. The cost of technology is rising. Consumers can't afford to buy laptops and smartphones, and artificial intelligence might slow down the pace of development. But there is a solution: seabed mining. Ooh! The ocean contains so many valuable resources and minerals that there will be enough for everyone. Prices won't rise, progress will accelerate, everyone will be happy, and blah blah blah. What beautiful words! But there are also many risks. Companies want to extract metals from the seafloor and say they will take all the necessary measures to minimize harm to the environment. But they don't know the consequences. Nobody knows, since this seabed mining is an experimental technology. But unfortunately, this may be incredibly destructive. Yes, the shortage of natural resources is a real problem, but we must not solve it by exploiting the ocean. So, what can we do? There will be some suggestions at the end of this video, but for now, let's focus on the problem. So, have you ever heard of dark oxygen? Scientists recently discovered oxygen 2.5 miles beneath the surface of the Pacific Ocean that is produced without light and without photosynthesis. Do you understand what this means? The oxygen we breathe on land is generated by plants, trees, and sea algae through photosynthesis. But it turns out there's another way. In the deepest, darkest parts of the ocean lie strange, potato-shaped metallic lumps called polymetallic nodules. And these unique formations produce oxygen. They likely existed on Earth long before photosynthesis appeared, billions of years ago, which means studying this phenomenon could reveal countless secrets about our planet. Now for the bad news. These nodules contain a large amount of manganese, nickel, cobalt, and copper, which makes them a valuable resource for advanced battery manufacturing. Extracting this material could destroy the oldest chemical processes on Earth and interfere with critical scientific research. Moreover, we still don't know how significant dark oxygen is to the global ecosystem, or what consequences its extraction might cause. At the very least, it could threaten the extinction of all species that rely on dark oxygen to breathe. Now, this is far from the only problem associated with seabed mining. Imagine a massive tanker arriving at a specific location in the ocean, lowering a giant drill or a massive suction tube, similar to a vacuum cleaner, to the seafloor. Workers turn on loud motors. The drill crushes the ocean floor, and the suction tube pulls up sand. The entire process produces a deafening noise that can disrupt echolocation, for example. A blue whale sends a signal to a friend and suddenly hears the deafening roar of a drill. Now imagine the noise caused by dozens of such tankers, hundreds, thousands. How many fish species will be frightened and remain in constant stress? The consequences of this noise pollution are difficult to predict. In addition, seabed mining can pollute the ocean floor with sedimentary deposits. This is an even more serious threat to ocean life. Here's why. A huge pump sucks up massive amounts of sand. On board the ship, the sand is processed. People extract valuable materials, metals, and other useful substances, while all the leftover sand is dumped back into the ocean. Tons of processed sand slowly settle back to the seafloor, falling on the heads of marine creatures. It's like a dust storm or a cloud of dust that stretches for miles. While the residual material is being dumped, giant pumps suck in new tons of sand. Then, after processing, it falls back down. And the cycle continues over and over. In this way, seabed mining can harm not only dark oxygen, but also the regular one that fish breathe through their gills. As they filter water through their gills, they'll also filter sand particles. Unlike humans, they don't have respiratory masks. This is yet another serious blow to the ocean's biodiversity. And don't forget that along with the sand, the pumps may also draw in octopuses, corals, crabs, and other crawling marine creatures. All of them are part of a fragile ecological chain. For example, sea pigs are deep-sea creatures with transparent bodies resembling snails and jellyfish. They're very fragile and can only survive under high pressure. If brought to the surface, they disintegrate. They don't swim but walk along the seafloor and serve a very important role. As scavengers, these animals clean the ocean floor of debris. They are essentially the ocean's janitors. Crabs even use them for transportation and protection from predators. Since sea pigs are toxic, enemies don't approach them, so crabs travel safely on their backs. What will happen if seabed mining pushes these amazing creatures to the brink of extinction? Who will clean the ocean floor of debris and decaying materials? No one knows what consequences the disappearance of these creatures might have. What about corals? Some live from 400 to 4,500 years. Some marine sponges live up to 11,000 years, and are among the oldest known living organisms. And yet, we risk destroying this ancient world for the sake of our technology. Imagine a massive tube appearing above your city right now, sucking up everything – houses, roads, streets, villages, people – and then dropping everything back except for metal objects. The streets would turn into a chaotic mess of dust and broken concrete. The same will happen to the seafloor, which is home to countless marine inhabitants. Deep seabed mining could destroy rare species of animals, even ones we don't yet know exist. The ocean floor in some areas has been studied less than the surface of the moon. We have no idea how we might harm nature with such operations. We have rarely mined minerals under such conditions. The technology is highly experimental, and we need all of this for making batteries, powering modern technology, and supporting artificial intelligence. Perhaps it's worth stopping and finding alternative sources. Perhaps we should not destroy our own home. Now, don't worry, we won't end this video on such a grim note. Of course there's a solution. To address the shortage of necessary metals and minerals, we don't need to destroy the ocean. Think back to the last time you replaced your phone or bought a new microwave. What did you do with the old devices? Did you throw them away? Sell them? Give them to friends? Every day, people discard tons of old electronics. Almost every old TV or computer contains small amounts of copper, nickel, and other elements. So if we collect this unwanted junk, extract the necessary metals and minerals, and reuse them, we can reduce the need for seabed mining. Companies spend millions of dollars building tankers, drilling rigs, and paying engineers. Why wouldn't they spend that money on organizing the collection of valuable metals and recycling old equipment? Every person could mine useful minerals right at home. And there's another solution. In 2026, many technology giants are going to switch to new sodium-ion batteries, which could eliminate the need for deep-sea mining. The thing is, today, battery production relies heavily on lithium. This element is difficult to extract, and working with it produces many chemical byproducts. One of the places where it's mined is the ocean. But the new batteries are much cheaper, essentially composed of the same element as table salt in your kitchen. They last longer and are far safer to use. Sodium-ion batteries are among the most promising technologies in the field of environmentally friendly materials today. Moreover, large corporations can use artificial intelligence to develop effective plans for extracting and replenishing necessary elements. So, don't despair. We are capable of saving the ocean and preserving the lives of millions of its inhabitants, if we choose to do so.
Earth has one huge connected global ocean that covers about 71% of the planet's surface. And since it's all water, it could make sense that it's the same height everywhere in the world, right? Strangely, at the Panama Canal, the Pacific Ocean is sitting higher than the Atlantic. And it gets even stranger. In the Indian Ocean, there's a massive gravity low where sea level sits dozens of feet lower than the global average. Let's figure out the mystery of the Pacific Ocean first. The difference in height between it and the Atlantic is, on average, about 8 inches, and that's a carefully measured, long-term difference. We aren't talking about waves or high tides here. The thing is, water expands when it's warm. The Pacific is usually warmer than the Atlantic, so its water kinda takes up more space. Salinity matters too. The Pacific is less salty in many regions. Fresher water is less dense, and less dense water sits a little higher. Then there are currents and winds. Strong trade winds, which are winds that blow from east to west just north and south of the equator, push massive amounts of water westward across the Pacific. That water piles up along continental edges. But probably the most important and unexpected factor is that gravity isn't the same everywhere on Earth. Continents, islands, and even underwater mountain chains pull on the ocean's surface. And the ocean actually follows Earth's uneven gravity field, not its geometric shape. Because of all this, global sea level can vary by up to 10 feet from one region to another. Now imagine how difficult it was to fight gravity and build a canal connecting these two oceans. engineers had to consider the Pacific-Atlantic height difference while working on the construction of the Panama Canal. Surprisingly, it turned out that it wasn't the main obstacle. There were much bigger problems, but we'll talk about them a bit later. So one day, people looked at Panama and thought, how hard could it be to dig a canal and connect two oceans? Very hard. The surface of Panama is steep, muddy, rainy, and unstable. So instead of digging in a sandbox, building a canal would be carving a trench through a wet, collapsing mountain. Engineers wanted a sea-level canal cut straight across so ships could cruise through without any locks or lifting. But Panama wouldn't cooperate. Every time workers dug into a hillside, the dirt slid right back down. During the rainy season, rivers flooded everything, burying the equipment. Then workers started getting sick constantly. At the time, scientists didn't fully understand that mosquitoes were spreading diseases, so outbreaks were literally wiping out crews. Thousands of people lost their lives. Eventually, the whole project collapsed, both financially and physically. Years later, the US tried again, but this time they decided to take nature into consideration. Instead of digging straight through at sea level, they built a giant water elevator system. It works like this. Ships enter huge chambers and the gates closed. Next, water fills in and the ships get lifted about 85 feet. That's basically the height of an 8-story building. That's where a huge artificial lake is. The ships cruise across that lake, then get lowered back down on the other side. It's like moving ships over a hill using bathtubs the size of skyscrapers. Anyway, what's the deal with Earth's gravity? Forget the idea that our planet is a perfect ball. Imagine it as a lumpy and spinning potato. The middle bulges out a bit because of the planet's rotation. The crust isn't uniform either. The density below the surface changes constantly. Some areas are heavy and dense, others light and floaty. That's what actually shapes gravity across the planet. Now, it's time for the geoid to enter our story. It's the shape the ocean would have if it were shaped only by Earth's gravity and rotation, with no waves, no winds, and no tides. In other words, if it just floated freely across this lumpy potato. Over dense areas, gravity pulls harder, so the water piles up. Over lighter areas, gravity is weaker, and the water sags. For example, there's a weird spot in the Indian Ocean where gravity is actually weaker than normal. And because of that, the sea level there sits more than 328 feet lower than the surrounding ocean. That's like water dipping down the height of a 30-story building. It forms a massive circular depression covering about 1.2 million square miles. It's officially called the Indian Ocean Geoid Low. Scientists first noticed it in 1948 during a gravity survey from a ship and have been puzzled about this phenomenon for years. Why would Earth's gravity be weaker in one patch of ocean? Finally, researchers think they might have figured it out. Deep under that part of the ocean, huge plumes of hot magma may be rising from the mantle, kind of like slow-mo lava blobs pushing upward from thousands of miles below. These upwellings can shift mass inside the planet, and when mass shifts, gravity shifts too. Lean mass underneath means a slightly weaker pull, and the ocean water sinking lower in that spot. To test the idea, researchers ran massive computer simulations. They basically rewound Earth's history back 140 million years to see how the region evolved. And guess what? Their models point to the breakup of an ancient ocean that no longer exists. Apparently, tectonic plates moved and pieces of crust sank deep into the mantle in that region. They likely disturbed the material below, setting off those magma plumes. So this gravity hole isn't a hole in the water. It's a dent in Earth's gravity field, caused by deep, planet-scale plumbing problems that started millions of years ago. The depression is so extreme that it influences ocean currents, sea level readings, and even satellite paths. That's how strong these mantle processes are, even millions of years after all that tectonic drama. The big question now is, will the Indian Ocean Geoid Low ever go away, or is it here to stay? Scientists aren't 100% sure. It all depends on how the masses inside Earth move around over time. Our planet's mantle isn't solid. It's constantly shifting, rising in plumes and sinking in slabs. These slow and deep motions can either keep the gravity low intact for millions of years or eventually smooth it out. Think of it like a giant slow-moving lava lamp under the ocean. Over a few 100 million years, the blob could shift enough to erase the dip, or not. In any case, the study gives some interesting ideas and might push experts to dig deeper. The older research only modeled sinking cold slabs in the mantle. Now, the simulations include hot, rising magma plumes. They were probably key to forming the low in the first place. But there are also missing pieces in the simulation. For example, the famous Réunion hotspot, a massive mantle plume that erupted around 65 million years ago, forming the Deccan traps across India. That eruption dumped lava over half of India. It was one of the biggest volcanic events in Earth's history. Without that plume in the simulation, some of the geoid predictions might be off. There are also mismatches between the model and reality. The predicted shape of the Earth's surface doesn't perfectly match actual measurements, especially in the Pacific, Africa, and Eurasia. The researchers say there's about an 80% correlation, which is quite good, but not perfect. Unfortunately, the simulation can't capture every detail yet. The lead researcher explains why. We just don't know exactly what Earth looked like millions of years ago. Plates were shifting, oceans were moving, and continents were crashing into each other, so there's a lot we just don't know. The models can only give us a rough idea of what the past looked like. Still, despite the small errors, the main takeaway is the following. The Indian Ocean geoid low is massive and shaped by deep mantle plumes and ancient tectonic events. It might change over the next hundreds of millions of years, or it might stick around. It's also a reminder that Earth is not a perfect smooth ball we like to imagine.
So, what do you like to listen to? Music? Podcasts? Maybe the sound of rain or the crackling of a campfire. But what about listening to the ocean? Not the familiar crash of waves on the shore, but sounds captured deep on the cold ocean floor. Sounds that send chills down your spine. Sounds of something big, dark, and possibly alive. And the most unsettling part is this. The true nature of some of these sounds remains a complete mystery to this day. In 1997, something strange echoed through the Pacific Ocean. Deep beneath the surface, far off the coast of South America, a sound appeared so powerful that it instantly unsettled scientists. It was ultra-low in frequency, massively loud, and unlike anything recorded before. The signal was later given a simple name, the bloop. At first glance, the bloop sounds harmless, almost playful, but what it represented was anything but. It was so intense that it could be detected by sensors nearly 3,000 miles away. Imagine standing in New York and hearing something happening in Los Angeles. Now imagine that noise travel through deep ocean water, terrifying marine life and oceanographers. Whatever produced it had to be enormous. The signal carried patterns that felt like its source was some living creature. Whales were the first suspects, but even the blue whale, the largest animal in the world, simply couldn't generate a sound that loud. The numbers didn't add up, and that's when speculation took over. If something could produce the bloop, it would have to be larger than anything swimming in today's oceans. People began imagining creatures of impossible size, ancient sea monsters, the kraken. Some even whispered about the megalodon, a prehistoric giant shark thought to have gone extinct millions of years ago, and featured in dozens of videos right here on the bright side. The mystery only grew deeper when scientists mapped the approximate location of the sound's origin. It came from a region close to Point Nemo, the most remote place on Earth. This spot in the Pacific Ocean lies more than 1,000 miles away from the nearest land in every direction. It's so isolated that it's often called the oceanic pole of inaccessibility. Point Nemo is a place few humans will ever see. Because of its remoteness, it has become a kind of graveyard for defunct satellites and space debris. When spacecraft are decommissioned, they are often guided to fall into these waters. It's quiet, empty, almost untouched, and yet Something powerful had screamed from nearby. For fans of cosmic horror, this detail felt oddly familiar. In the fictional universe of writer H.P. Lovecraft, the ancient sunken city of R'lyeh lies beneath the ocean near this very region. According to the stories, R'lyeh is where the monstrous entity Cthulhu sleeps. It's a powerful, scary, intelligent creature lying dormant for thousands of years, ready to awaken and bring about the end of the world. Of course, Cthulhu is pure fiction. Lovecraft never claimed otherwise. But once the internet made the connection, the idea took on a life of its own. But science eventually caught up. The bloop recording is still easy to find online. You can listen to it yourself. But it sounds so innocuous that you'll probably be disappointed. And today, we know with certainty that it didn't come from a living creature. Researchers later confirmed that the sound was produced by ice, specifically by an ice quake. Now, ice quakes occur when enormous icebergs fracture, crack, and break away from glaciers. When this happens, they release tremendous amounts of energy, generating ultra-low frequency sounds that can travel across entire ocean basins. These sounds are similar to biological calls, especially when recorded from far away and distorted by water. In fact, scientists compared the bloop to other known icequake recordings and found striking similarities. The source wasn't a monster. It was Antarctica itself during shifting, breaking, and reshaping. For many people, this idea brought mixed emotions. On forums like Reddit, some openly admitted they preferred the idea of a giant unknown life form. Yup. Another strange sound was captured in the early 1980s, deep in the South Pacific, during a scientific expedition near New Zealand. Researchers were exploring the South Fiji Basin, where the ocean floor lies more than 2.5 miles beneath the surface. There were short, sharp, repeating noises echoing through the water. 4 distinct bursts, each one sounding uncannily like a duck's quack. So, researchers called it the bio-duck. The sound was rhythmic and consistent. Eventually, the team concluded that the source had to be biological, but identifying exactly what made the sound proved impossible. After sharing the data with colleagues in Australia, did they realize something even stranger? Similar sounds had been recorded in other parts of New Zealand and Australian waters. Decades later, the mystery remains unsolved. Some scientists believe the quacks may not be random at all. They could be a form of communication. Perhaps the sounds may come from Antarctic minke whales, though no direct proof exists. Scientists also noticed that there were several sources of sounds, and when one source spoke, the others fell silent, as if they were listening. It may have been a conversation echoing through the deep, in a language we still don't understand. Imagine a terrifying alarm blaring inside a secret laboratory, announcing that a monster from another planet has broken free. It's an ugly sound, loud, piercing, and oppressive, the kind that makes your skin crawl. In August of 1991, scientists recorded something eerily similar. Not in a lab, but deep beneath the Pacific Ocean. Across vast areas of the ocean, a strange, repeating signal began to appear at different times. It consisted of narrow, rising tones that lasted several seconds each. Researchers named this sound upsweep. It's detected most often during the spring and fall, leading scientists to believe it may be connected to seasonal environmental changes or changes in the source itself. But what exactly was producing it? No one knows for sure. The only thing scientists can say with confidence is that upsweep appeared near areas of suspected volcanic activity. But if this sound is natural, why does it seem so precise? So consistent? It almost feels artificial, as if a secret underwater facility is periodically broadcasting a distress signal from the depths of the ocean. Since its discovery in 1991, the upsweep signal has gradually weakened, making it one of the strangest and most unexplained phenomena ever recorded beneath the ocean. Now, there's another mysterious sound known simply as slow down. True to its name, this signal steadily decreases in frequency over 7 minutes before fading into complete silence. It was recorded in May 1997 on a hydrophone array located in the eastern equatorial Pacific Ocean. At first, slow down doesn't seem especially loud. But here's the chilling part. It was picked up by 3 separate sensors placed nearly 3,100 miles apart. Imagine how deafening and terrifying it was near the source itself. So, what caused it? The most widely accepted theory suggests that a massive drifting iceberg slowly came to a stop and ran aground. The idea is surprisingly plausible. A colossal block of ice is scraping along the seafloor, grinding forward until it finally halts. The location supports this theory as well, since the sound originated near shallow waters and small islands. Because of this, many scientists classify slow down alongside the bloop as a cryogenic noise caused by ice. Still, it remains just a theory. Officially, the sound has never been identified. And there's yet another eerie recording from the ocean. This one sounds like a moan, but scientists named it whistle. Go figure. It was recorded in 1997 and gives the unsettling impression that something enormous is sitting on the ocean floor and whistling. Researchers believe that something could be an underwater volcano. When they compared the whistle signal to previously recorded volcanic sounds from the Eastern Pacific, they found them very similar to each other. Most likely, all these sounds are of a natural source, volcanic eruption or iceberg collision. But it's still pretty scary to hear something like this while driving. It would be especially unpleasant to be directly above an erupting underwater volcano. Well, yeah. Over 1,500 people lost their lives in this part of the ocean, so maybe it's a prudent idea to stay away from it. The spot where RMS Titanic sank remains dangerous. I mean, yeah, there are still huge icebergs out there, but there are even bigger threats lurking beneath the surface. Titanic is sitting about 12,500 feet underwater, nearly 400 miles southeast of Newfoundland. It's been down there for over 100 years. So, over time, the wreck's just been falling apart little by little. The infamous ship is rusting just like any iron or steel structure would be underwater. Chemically, when you mix iron, oxygen, and water, that combo sets off a reaction that creates iron oxide, and that's what leads to corrosion. So, steel plates, beams, all that stuff is getting weaker. Parts of the liner are caving in, like the ceiling in the captain's bathroom and a section of the railing that collapsed not too long ago. But in the case of Titanic, a lot of that corrosion is actually being caused by iron-eating bacteria. When the Titanic sank, it split into 2 big pieces, the bow and the stern, which landed nearly 2,000 feet apart on the ocean floor. And now both pieces are covered in this biofilm, a living blanket of bacteria, marine fungi, and all sorts of other microbes. Over time, microbes feeding on the ship's iron have created these things called rusticles, and they are actually speeding up the wreck's decay. Scientists say the stern is breaking down way faster than the bow, mostly because it took more damage when the ship sank. And now, thanks to all that bacterial activity, the stern could be deteriorating as much as 40 years ahead of the bow. So yeah, microbes have been thriving and flourishing down there. If you are a germaphobe, that probably sounds like a total nightmare. But honestly, it's not that bad. For one, they don't even look gross. These rusticles actually look kind of cool, like ice crystals or tiny diamonds clinging to the wreck. And don't worry, you are not in danger. As long as you keep a safe distance from the wreck, no direct contact, and definitely don't go poking around inside, there really is no risk. Speaking of getting dangerously close, we've got to mention the Titan submersible disaster. You know, the one that catastrophically imploded back in 2023 during a trip to the Titanic wreck. Sadly, all 5 people on board lost their lives. Even though this trip was sold as a tourist adventure, going that deep in the ocean is no joke. It's terrifying, cold, and dark. Sunlight gets absorbed by water and can't reach much farther than about 3,300 feet below the surface. Past that point, the ocean is in total darkness all the time. Titanic lies within a region known as the Midnight Zone for this very reason. The few brave people who have visited the wreck say the descent takes over 2 hours through complete darkness. Then, out of nowhere, the ocean floor just pops into view, lit up by the submersible's lights. The second big challenge is actually finding the wreck. At that depth, navigating is no easy task. When you reach the bottom, you really don't know exactly where you are. You're just kind of fumbling around in the dark, knowing that Titanic is somewhere down there, but you can't see it. However, detailed maps of the Titanic site, made from decades of high-res scans, really do help. As the wreck starts to come into view, they can use those maps to stay on track. Plus, sonar and sensors let the crew notice features and objects even if they're way beyond the sub's tiny light pool. For example, the Titan submersible had a sensor called the Doppler velocity log. This one sent out sound waves to measure how fast the sub is moving and how deep it is, based on its distance from the ocean floor. Still, passengers on previous trips to Titanic in this submersible have said how tough it is to find their way once they reach the ocean floor. And we can't forget about the pressure. The deeper you go in the ocean, the more pressure the water puts on everything. And the pressure is crazy high at the Titanic's wreck site. To put it into perspective, it is about 200 times the pressure inside a car tire. That's why submersibles need super thick walls to handle it. So yeah, the water around Titanic has creepy microbes, pitch-black darkness, and insane pressure. But there is one more thing happening down there, and that's unpredictable currents. You're familiar with them. I mean, when you swim in the sea, you can usually feel the currents pulling you from side to side. But the deep ocean has its own set of underwater currents too. They're not as strong as the ones you feel on the surface, but they can still move massive amounts of water around. These currents can be caused by things like wind, differences in water temperature and salt, and even strange storms down on the ocean floor called benthic storms. They can get intense and stir up the sea bottom. Now, like I mentioned earlier, the Titanic wreck is in 2 big pieces, the front and the back, and researchers have been checking out the seabed of the surrounding area. One part of the wreck is near this cold underwater current called the Western Boundary Undercurrent. It flows south and moves mud and sand along the ocean floor, creating ripples and patterns that show how strong or weak the current is. Most of the time, the currents there aren't very strong. They even found sand ripples near where all the Titanic debris landed, like furniture, coal, and just random stuff from the ship. And those ripples are showing a current flowing from east to west. But inside the main wreck site, things get a little wilder. The water flows more from northwest to southwest, probably because all the huge chunks of the ship are messing with the flow. Around the south side of Titanic's bow, the currents get unpredictable too. They keep switching directions, from northeast to northwest to even southwest. It's like the ocean's just doing its own thing down there. Experts think that over time, all this shifting water is going to slowly bury Titanic under layers of mud and sand. Little by little, the wreck could just fade away and disappear beneath the ocean floor. Alright, now it's time to get to the obvious issue here: icebergs. Yep, they're still a problem for ships today. In 2023, around 380 icebergs flowed into the busy shipping routes between North America and Europe. That's a problem. You see, the bigger the iceberg, the easier it is to spot and avoid. Smaller ice is a lot harder to detect, though it's no less dangerous. And that's because the most dangerous part is underwater, where no one can see it. Think about the iceberg that sank Titanic. Passengers saw about 100 feet of it above the water. but it's believed that's only 16% of its total size. Experts say the rest, hidden beneath the waves and much larger than what's visible, could stretch down several hundred feet. Now, the good news is that, unlike Titanic's day, we have much more technology now to spot icebergs in time. Modern ships have radar and satellite imagery that can pick up icy threats hiding in the dark. Some vessels even use sonar and thermal imaging to see through fog, helping the crew to spot icebergs above the surface. GPS and AIS pick safer routes, and monitoring centers around the globe send out real-time alerts, like having a personal iceberg spotting assistant. So, yes, it is a massive upgrade from just relying on binoculars. You won't have to worry about icebergs on your next cruise vacation, even if it passes alongside Titanic's route. But just to be extra safe, try not to travel with anyone named Jack or Rose, and never play the violin while on board. Just saying.
See this big spot under the water near the shore? It's a coral reef. It beckons you to swim closer, but be careful. If you get there, it could be the last swim of your life. Stay away from the reef. But why? Why are coral reefs so dangerous? Let's figure it out. First, make your guess about what a coral reef is. An underwater cliff? Rocks? A coastal landscape? Some spot where shells live? Close, but not true. In short, a coral reef is a living thing. What we see in shallow tropical waters are colonies of organisms called coral polyps. They are distant relatives of jellyfish and anemones with amazing superpowers. They can absorb calcium from the water. When they do this, they convert calcium into hard limestone rocks. These rocks, like building blocks, form solid coral reefs and settle on the seabed. But there are soft coral reefs that look like plants. They float freely with the currents, swing in different directions, and seem to pulsate under the water. They don't have solid coral blocks, but they can grow tree-like cores to maintain their position. Both hard and soft coral reefs are beautiful creatures, but at the same time, they are very dangerous. Many ships were wrecked when they hit shallow water, as the sharp edges of coral reefs ripped through their hulls. But what danger is there for someone swimming alone, who isn't going to hit the reef? You can just scuba dive and enjoy the beautiful views of coral polyps, but be prepared to encounter unexpected and unpleasant creatures. A coral reef is not just a living colony, it's a home for thousands of diverse marine creatures. And some of them can be very dangerous for humans. Like the blue-ringed octopus, for example. This is a tiny creature that you will definitely notice thanks to the bright spots on its body, but don't touch it with your hand, as it's one of the most venomous creatures on Earth. The amount of toxic venom carried by this octopus can harm 26 people, and these people are unlikely to survive this encounter. The poison works within a few minutes, and there's no antidote in the world. What makes it even more dangerous is that the octopus's sting is painless. You probably won't even know you've been stung until the first symptoms appear: body paralysis, respiratory problems, and cardiac arrest. But even if you don't notice the octopus and swim past, you'll probably notice the box jellyfish, whose tentacles can reach several feet in length. It looks like a creature from deep space, and you better not approach it. The box jellyfish is considered the world's most venomous creature. There are special cells in their tentacles that release a toxin called nematocysts. Over the past 100 years, roughly 70 people lost their lives after encountering these jellyfish. But most likely the number is much higher. We just don't know about all such cases. Unlike the painless sting of the blue-ringed octopus, the encounter with a box jellyfish hurts. Another dangerous inhabitant of coral reefs is a rock. Yes, take a look. It's just a rock that's part of the reef. But wait a minute, it seems to be moving. Don't touch it. It's incredibly venomous. By now, you've probably already realized that this is not a stone. This is the stonefish. And this sullen-looking guy is one of the most venomous fish on the planet. Do you see those little spikes along its spine? The fish raises them when it feels in danger. If the toxin covering these spikes enters your body, you have less than an hour to take the antidote. If you don't make it in time, better not dwell on the worst-case scenario. Do you still want to swim closer to the coral reef? If so, go ahead. There are other scary creatures there. This one, for example, doesn't pretend to be a rock or something harmless. It looks dangerous, and it is dangerous. It's the moray eel. These underwater snakes are not venomous, but meeting them can be unpleasant. They can bite quite painfully, but only if you disturb them in their burrows. Of course, you probably won't want to tease these creatures, but you might accidentally approach their burrow without knowing they live there and poke it with your finger. Once you do it, get ready for a payback strike. By the way, moray eels are poisonous because they eat toxic algae and fish. However, they can't use this poison against you unless you try to eat them. As you approach the coral reef, you may encounter a flying dagger. This is the needlefish, a thin, fast fish with a sharp nose and prickly needle-like teeth. It swims near the surface close to coral reefs at high speed and then jumps out of the water and flies at a speed of 37 miles per hour. Many people have reported getting seriously injured by this guy. This one looks like barbed wire shaped like a star. Hundreds of sharp needles cover the crown of thorns starfish's body, and you'd better not touch them. Each thorn on their body contains dangerous toxins that cause pain, nausea, swelling, and can even lead to anaphylactic shock. Coral reefs are not just a place for them to hang out, but also food. This starfish bulges out its stomach, covers the reef surface with it, and absorbs nutrients from it. It's like something straight out of a sci-fi horror movie. But don't think that corals are something scary and dangerous. In fact, coral reefs are some of the most useful things in the ocean. They even save people's lives. Do you know that lines of coral reefs cushion the impact of tsunamis and protect the shores from flooding? Some large reefs, like the Great Barrier Reef, are the boundary between the open sea and shallow waters. They stretch along the coast and form a protective wall that serves as a barrier against tsunamis and landslides. During a storm, rocky coral reefs disperse large waves and soften their impacts on the shore. But the coolest thing is that corals help your Instagram profile look better. What? Yes, that's right. Do you know these beautiful paradise-style photos when the water near the shore is blue and the sand on the beach is white? So sand gets this unique color thanks to corals. As you already know, coral bodies are made up of calcium carbonate. When waves and storms destroy corals, they wash out these calcium particles directly onto the shore. Besides corals, tiny bits of crushed seashells also end up there. Over time, layer by layer, they build up to form white sandy beaches. By the way, parrotfish are also involved in creating this beauty. These little fish feed on algae that stick to coral reefs, so they also consume pieces of coral along with their food. Then, when they're full, they release the coral particles, which eventually become the white sand. One such fish releases about 200 pounds of coral waste per year. So in a sense, this white sand appears because parrotfish go number 2. Coral reefs are ancient. The average reef grows at a rate of about 0.7 inches per year. And now look at their sizes. The Great Barrier Reef stretches for more than 1,430 miles, and it's been growing for 8,000 years. It's been here since people began to develop agriculture, domesticate animals, and build the first settlements. And some reefs are much, much older. That's why it's so important to preserve this unique natural wonder. And humans end up destroying it, often when ships accidentally crash into coral reefs. When this happens, it ruins the home for thousands of sea creatures. Ocean ecosystems get majorly impacted. But we also try to improve the situation. Coast guards protect the areas where coral reefs grow so that no vessel can approach them. These majestic creatures are a crucial part of nature. And this is another equally important reason why we should stay away from them.